So for this first page on the practice problems packet, we've got shape 1, which is this half circle, shape 2, which is this full square, and then shape 3, which is this negative triangle, which is kind of upside down backwards in the reference table. So shape 1, 2, and 3, they're all going to be referenced from the origin, and the reason I did this one is kind of a challenge project. The origin's kind of not part or not directly on the shape. It would be just tangent to the half circle and just on the bottom of that right there. So that right there is the origin. Now the areas I'll calculate the same way, like we calculate the areas of the shapes. So the half circle, pi r squared divided by 2, I got 1.57. The second shape is a 2 by 2 square, so I got an area of 4. And shape 3, we're removing it, so I'm going to make it negative. It's going to be, it's a 1 by 1, just because it's what's left here, so that's 1, and then this is 2, if that's 1, so this is going to be 1 by 1 in dimension, divided by 2, that's 0.5. Now what I put here is the same as what I'm going to put here. So 1.57, 4, and negative 0.5. Because these are the areas, it's just breaking it into two tables for clarity. Now the x bar location is the location of the centroid of that individual shape relative to the overall geometry origin. So for this half circle, on the reference table they have it in this orientation, so I'm just putting it that way to kind of show it to you this way. We come over 1 radius and then we go up to here, 4 times the radius divided by 3 pi, which is the formula of the reference table. So this distance, 4r divided by 3 pi. So 4 times the radius on this is a 1 divided by 3 times pi. Now in this orientation we went over 1. So they say x bar, and they say y bar is 4r 3 pi. The x and y location, the name x and y, only matter if it's in this location in this exact orientation. But really it's sitting this way in the overall geometry of the shape. So I don't care what was called x bar, y bar before. It's this location that I'm trying to find from here. So to get to there, I'm trying to work my way there, kind of using directions and then adding and subtracting on number lines to figure out where that point is. So coming over 1, just to get to this start of the half circle, and then going up 1 because that's that radius there. So I know my y bar has got to be 1 because that's how far I have to come up to get there. But the x bar I have to actually go backwards because I don't really know this distance off the top of my head, but I do know if it's 1 minus whatever this 4r divided by 3 pi was. So for the x bar for this shape, I got 0.576, which is 1 minus this. And the rough estimation, I did this on a calculator so I don't have it in front of me, but 4 times the radius of 1, so 4 divided by 3 times pi. Pay attention to order of operations. If you get a number for 4 divided by 3 pi that's above 1, something went wrong with the order of operations, because 4 divided by 9-ish should be somewhere below 0.5. So 1 minus that is 0.576. X bar, the x location for shape 2 is half of base, half of height. So half of 2 is 1, half height is 1 because it's too tall. Now to get here though from the origin, I'm coming over 1 just to get here, and then coming over another 1 to get under that. So the x bar is 1 and the y bar is, or sorry, the x bar is 2 and the y bar is 1. This was 1 as well for shape 1. Now shape 3 is upside down and backwards from the orientation on the reference table. The orientation on the reference table has it this way. They measure off the right angle over 1/3 of the base over 1/3 of the height. So that's 0.3 and 0.3. Repeating. but 0.3 and 0.3 from this top corner, when I go back to this as an overall shape, well, now I'm coming over 3, 1 and then 2, and I'm going up 2 to get to here. So I'm at the Cartesian coordinate 3, 2, but I gotta come back 0.3 and come down 0.3. So for the x location, I'm at 2.666, 2.6 repeating, because I came over 3, I came over 3 and then I went back 1/3, and then my y bar is going to be 1.6 repeating, because I went up 2 to get to this top and then I came down 1/3. From here I multiply across all the columns, 0.9048, negative 1.333 repeating. Over here, y bar 1.574, negative 0.83. So the formula in the reference table that's dealing with this, to get to the actual overall centroid of the overall shape, the overall balancing point of this whole shape is the product of kind of these weighted locations. So the sum of the x bar, or the overall x, this one, is the sum of the a times x bar location and the sum of the area. So that's, this is the sum of this column, and this is the sum of this column. Oops, sorry. So the overall x location on the balancing point of this overall shape is the sum of the ax column divided by the sum of the ay column. And then this is on the reference table as well. So the y location, the overall y location is the sum of a y over sum of the area. So the sum of my area is 5.07. This is the same thing over here. So for both of them, 5.07, 5.07. The AX bar, the sum of this, is 7.57. And then the sum of this column is 4.74. Oops, I wrote wrong down here. I meant to say 4.74. So now dividing that by that, up here I get 1.49, and then dividing these over here I get 0.935. So 0.935 is the location where if I had this shape and I had to balance it on the pen tip, I could just balance it ideally at this location, in theory. Now if I'm trying to figure out logically if this makes sense, if this shape was indeed symmetric, the line of symmetry would be about there. Well, we remove some of the stuff here. Removing weight from one part of the object is going to push the central, the balancing location, away from that point. So what should have been a nice balancing point at 1 in the y direction, so it's up from the 0 on the scale here. What would have been 1 is now 0.935. 1.49. The shape is the shape is 3 in length. Well, losing this is going to push it back a little bit, but we do have not a lot of material here, so that's kind of weighting it maybe back a little bit more. So having it somewhere in the middle makes sense logically. So that's how you go about and kind of solve through this complex shape to find the centroid. Let me know if you have any questions.